Okay, greetings everyone, and a very warm welcome. Thank you all for attending our Canes on Canes event during the first week of hurricane season. My name is Sharan Majumda, and I'm a professor in the Department of Atmospheric Sciences at the University of Miami's Rosenstiel School. Our school is located on Virginia Key, and is on the left side of the photo that you can see. We have undergraduate, professional masters and PhD programs, and our faculty provide first-class instruction and research opportunities. We're very committed to hurricane research, especially training the next generation of hurricane scientists who you'll be hearing from. Our environment is quite unique as we're located across the causeway from our close collaborators at NOAA's Hurricane Research Division. They're the ones who fly in the hurricanes, and they're on the right-hand side of the photo. We also have a long-standing relationship with the National Hurricane Center, who are inland, a few miles away. So we invite you all to engage with this, and you can find information about our programs on our website with frequent news updates on our social media. So now it's time to pass the torch to our next generation of hurricane scientists. And first up is Quinton Law.
Hi, everyone. Thank you for joining today. We're really excited to have you here. So I'm going to give you a bit of an outline of today's webinar. We're going to start off by taking about the first 40 minutes or so and giving a presentation. So I'll tell you a little bit more about what Canes on Canes is. Then we'll move on to more about hurricane research here at the University of Miami's Rosenstiel School. Then we're going to talk about the 2021 hurricane season outlook and how you should interpret it. And finally, we're going to spend the last 20 minutes or so, we're going to talk about hurricane preparedness, and then we'll spend the last 20 minutes or so taking your questions so that we can answer some of the things that we maybe didn't present on today. Now, I'd like to remind you that if you have any questions at any time during this presentation, please go ahead and put it in the Q&A tab at the bottom of your Zoom window. We're going to try to answer as many of these as possible in the second half of the webinar, but it definitely helps if you're able to put your questions when you have them earlier on in the presentation so that we can get to them later and you don't forget about them. So what is Canes on Canes? Well, we're a group of Rosenstiel School graduate and undergraduate students who either research hurricanes or study related topics in the atmospheric sciences. Our goal is to educate and engage the public about the science of hurricanes and hurricane preparedness. So here are just a few a bit old photos pre-COVID-19 of our group. Just some of our members, but we have a lot more members that aren't actually visible in this photo and that are going to be on today telling you a bit more about hurricanes. So I'm going to take the time now to both introduce myself and have my colleagues introduce themselves. My name is Quinton Law. I'm a PhD student, a second-year PhD student in atmospheric science, and I study hurricanes and how they form. I also have a degree in meteorology from Texas A&M. Tyreek?
Hi, I'm Tyreek Frazier. I'm an undergraduate student in meteorology going into my senior year.
Hello, I'm Kurt Hansen. I'm a PhD candidate here at the Rosenstiel School. I have a degree in atmospheric science from the University at Albany. Tori?
Yes, thank you. Torrey White, second year Master's Professional Science candidate.
Hi, I'm Mary Beth Arcodia. I'm a PhD student here at the Rosenstiel School studying climate variability, and I have a degree in math from Georgetown University.
Well, thank you, everyone, and you will be hearing from everyone else in the later in the presentation, so stay tuned. They'll also be here to answer your questions later on. All right, so a little history on our organization. We were founded in 2014. This is out of a need to collaborate on some of the hurricane-related outreach that was happening here at the University of Miami's Rosenstiel School. One thing about the Rosenstiel School is that there's a lot of outreach happening all the time, and this includes in hurricanes. And so this was basically an idea to let's combine all of these outreach activities into one group so we can coordinate. We're mentored by hurricane researcher Brian McNulty, who you may have actually seen on TV or in the news because he does a lot of engagement with the public. And I also like to shout out our founding members who are in this photo because they basically laid the foundation for our organization today. We do a lot of various kinds of outreach. The first what we do primarily is education. So we do school visits. This includes in-person and recently virtual talks to all levels of classrooms from elementary through high school to college. We do tabletop experiments at live school events and school cafeterias. We've talked with students visiting the Rosenstiel School and showed them around campus and talked about hurricanes. And we've also done some professional development for teachers and educators so they can actually bring the science of hurricanes into their classrooms. We also do a lot of community outreach in the South Florida area. This has included a ton of different things, including tabletop activities at local museums like the Frost Museum of Science. We've done preparedness talks at local community centers. We also engage with local civic groups, including the Rotary Club and also Piano Slam, which is a nonprofit. We've even done sporting events, including the World Sailing Cup a few years ago. So we try to stay engaged in any way we can with the local community and bring the science of hurricanes and hurricane preparedness to everyone. So one thing I'd like to point out before we get more into the presentation, we can give our talks in person in the future, hopefully in South Florida, but also we can do a lot of things virtually. We can cater to any age group and talk about anything related to hurricanes and climate change or hurricane preparedness. So if you're interested at all at bringing this to your local area, please visit our website or contact the Rosenstiel School and we can get in touch. So now I'm going to pass it off to Tyreek, who's going to tell us a little bit more about what a hurricane is.
Thank you, Quinton. So what is a hurricane? A hurricane is a type of storm called a tropical cyclone that forms over tropical or subtropical waters. But the official definition is a rapidly rotating storm system with a low pressure center, closed circulation, and strong winds that are greater than 74 miles per hour. And also has a spiral arrangement of thunderstorms that can produce heavy rains and even spin off tornadoes in some cases. And this image on the screen here is of Hurricane Irma from the GOES-16 satellite. And Hurricane Irma is actually 11 miles tall. And something interesting is that at the top of a very strong hurricane like Irma, you'll find the coldest temperatures on the planet. When looking at the eye itself, we can look from the top down using satellites, or we can use hurricane hunter planes. They actually fly in to gather data and they get a glimpse of the eye at the same time. And when you have a very strong and well-developed hurricane like the two on the screen, you also have a very clear and well-defined eye. And then you get an example of what's called the stadium effect, which is what we see on the screen. It's essentially you're looking at the eye wall surrounding the eye of the hurricane and it resembles a stadium. And then in this animation, it's Hurricane Harvey from the satellite view. And you can see the eye is pretty well defined and it makes sense because this hurricane was also very strong. And then here's a radar loop of Hurricane Irma from 2017, kind of showing you the structure of the hurricane. You can see the eye is the area in the middle where you see no precipitation. And then the eye wall is the area immediately outside of the eye where the precipitation is more, denoted by the red color, the warmer colors. And then the rain bands are all of the stripes of warmer colored around the eye wall. In terms of hurricane season itself, it's officially from June 1st to November 30th, but storms can and do form outside of this range. And in fact, this year we already had one early storm, it was Anna. And for the Atlantic, the August to October are the peak months, but for South Florida, October is the most peak month. And then in the chart to the bottom left, it's just showing the frequency of the different types of storms over the different months. And then the graphic to the right is showing basically the average storm tracks of for South Florida over the data that we have over the past 70 years. And you look from June to July, there's very few storms. And then August to October, it ramps up quite significantly. And then in November, there's once again very few storms. In terms of hurricanes, they're very complex in nature and the research is also very complex to understand. So I'm going to hand it off to Kurt to talk about what's going on at the Rosenstiel School in terms of research.
I'll start off with Professor David Nolan. He's a professor here at the Rosenstiel School and also the head of the Department of Atmospheric Sciences. Dave Nolan is working on research of landfalling hurricanes. And here we can see a snapshot image of a simulation of Hurricane Wilma, which made landfall in South Florida in 2005. This image shows the maximum sustained winds over different parts of Florida and the surrounding ocean. And two things we can learn from this image is that the wind speeds drop drastically as they move over land. So we can see that these high warm temperatures indicating strong winds decrease to bluer temperatures as they move over land. Also, over urban areas where there's buildings that cause more friction and higher roughness, the wind speeds decrease even further. So we can actually see the Miami-Dade metropolitan area in this wind map. This plot on the right here shows actual observations from around Naples, Florida, compared to the wind speeds produced by the simulation. And we can see that the simulation is very accurate, so we can trust in these results. So James Halibiak is a fifth-year PhD student under Professor Nolan. His research also involves understanding how changes in the surface conditions near land affect the near surface winds with a hurricane. So he created simulations of hurricanes making landfall over different land surfaces and measured how winds changed over land. So in this plot, these storms are moving from east or from the right side of the plot to the west, left side of the plot, along this black line kind of running through the center. And this coast is marked, the artificial coastline is marked by a vertical solid line. The surface roughness increases from left to right, and the soil saturation increases from bottom to top. So we can see that by increasing the surface roughness, it's very important in determining hurricane strength inland. And by increasing the roughness, we increase the friction, which drastically reduces the wind footprint, or maximum wind speed measured at each land point. The soil moisture is less important, but does help to sustain strong winds far from the storm center. So Ryder is a third-year PhD student under Professor Nolan, studying how ice particles in hurricanes affect flooding events associated with landfalling hurricanes. They're looking specifically at the case of Hurricane Florence in 2018, which was a slow-moving and weak hurricane at the time of its landfall in North Carolina, bringing with it record-breaking rainfall and incredible damage. Florence and other weak hurricanes can be lopsided, so special methods are needed to analyze these types of storms. Ryder is currently working on distinguishing between heavy and light rainfall, and once the separation has been made, they will investigate the different types of ice associated with the different rainfall rates. Rebecca Evans is a fifth-year PhD student that's working with Professor Nolan, studying the effects of the day-night cycle on hurricanes. So here we see a diagram of a hurricane in the troposphere with lots of winds and chaotic motion. And when the sun sets and rises, you get pulses of motion within the hurricane. And this makes the layer above the hurricane at the stratosphere form ripples like you would see in a pond. The waves and ripples in the atmosphere are invisible to the human eye, but they're important because they carry lots of energy and momentum to other parts of the atmosphere. So in simulations of hurricanes, we can capture these types of waves to figure out how important they are for the amount of energy and momentum that they release into the atmosphere. So we can see that simulation right here. Nick Shay is a professor at the Rosenstiel School who specializes on the impact of ocean temperature on hurricanes. So this picture on the left shows his former student Josh Wadler in a hurricane hunter flight helping measure the wind speed and surface temperature in a hurricane. This data has helped us learn that the depth of warm water is important for predicting hurricane intensity. And this plot in the middle shows how high ocean heat content helped fuel Hurricane Laura's rapid intensification. Some recent work that he's working on is how horizontal gradients or changes in ocean temperature can impact hurricane strength. Sharan Majumda is a professor working on several areas of research. One of his projects is on improving hurricane communication, and you can kind of help us with this research right now. So looking at this picture on the left of the forecast cone, can this graphic tell you the size of this hurricane? So if you said no, you're correct. But if you said yes, don't feel bad, 44% of people got this question wrong. So Sharan is looking at alternative ways to communicate hurricane risk, like this graphic on the right. This plot shows the estimated threat from wind, storm surge, flooding rains, and tornadoes. Brian McNulty is a researcher working with Sharan Majumdar, David Nolan, and Renato Molina. And this is some of the work that he's done with Renato. So hurricane forecasts have already improved quite a bit over the years, but are further improvements still valuable? A large-scale survey of people impacted by Hurricanes Michael and Florence determined the public's willingness to pay for future improvements and which storm attributes they value more. So people value improvements to forecast intensity most of all, but these results show that the public still values further improvement in forecast accuracy of rainfall and track as well. Most importantly, the perceived value of these forecasts greatly exceeds the current operational program costs. So people are willing to pay much more for better forecasts. Quinton Law is a second-year PhD student working with Professor Majumdar. He studies how interactions between waves in the atmosphere govern the formation of hurricanes in the Atlantic. These animations show two kinds of waves passing each other and interacting over the Atlantic Ocean. The stars moving from east to west are African easterly waves. Hurricanes in the Atlantic Ocean often form from these types of waves. Meanwhile, the coloring, the brown and green, show the footprint of another type of atmospheric wave called a convectively coupled Kelvin wave. His research studies how these two waves can affect each other and make hurricane formation more or less likely. Ben Kertman is a professor at the Rosenstiel School and the director of the NOAA Cooperative Institute for Marine and Atmospheric Studies, or CMAS. He and his students research climate events like the Madden-Julian Oscillation and El Nino, which can impact hurricanes. His students, me and Mary Beth included, created the Season Chaos blogs, which cover a variety of topics related to subseasonal prediction. And our blog just released our interpretation of the 2021 hurricane season forecast. So go check it out. So Kurt Hansen, who is me, is a fifth-year PhD student working with professors Majumda and Kertman. And my research is on predicting hurricanes weeks in advance in the subseasonal range. I found that vertical wind shear, which is the difference in winds at different levels of the atmosphere, is important for subseasonal prediction. So strong vertical wind shear can act to rip storms apart. This pattern here of shear signals an active period in the Atlantic. These green patterns indicate less shear, which would be more favorable for hurricanes. However, you'll also see that there's an area of high shear that's associated with more hurricanes, which is counterintuitive. This high shear pattern is probably associated with weather that's both high up in the atmosphere and further north. This shear pattern helped to improve simple statistical forecasts out to 10 days, but could be useful for much longer lead times. The Alfred C. Glassell Jr. Sustain Laboratory, which stands for Surge Structure Atmosphere Interaction, directed by Brian Haus, is a unique resource for studying complex air-sea interactions of wind, waves, and shorelines. This powerful wind wave tank can create Category 5 hurricane force winds up to 155 miles per hour. And it is enclosed in clear acrylic so that water and wind interactions can be monitored in a 3D environment. Students and faculty use it for a plethora of studies ranging from air-sea interactions to ocean temperature, coral reef restoration, and design of coastal structures. Pyson Tan is one of those students. By simulating hurricanes in the lab, Pyson explores how wind powers the ocean in storms and improves the next generation of hurricane models. Another group uses the tank to create sea hives, a marine and estuarine shoreline protection system that employs artificial structures to dissipate wave energy. Through this research, we can provide the residents of South Florida with a safer tomorrow. Milan Curcic is a postdoc working with Professor Brian Haus in the Sustain Lab here at the Rosenstiel School. He works on ocean modeling under hurricane conditions. And here we can see a simulation of the ocean sea surface temperatures during Hurricane Dorian in 2019. In just a sec, we'll see when Hurricane was a powerful and slow-moving Category 5 storm over the Bahamas, it caused a lot of cooling. So right here in the simulation, Dorian stalls at about peak intensity, and we see a lot of blue colors appear, indicating the cooling of sea surface temperatures. Lev Looney is a student here at Rasmus that works with Greg Fultz at NOAA and Professor Kertman. He researches the role of ocean stratification on tropical cyclone intensity changes. So ocean stratification is the change in ocean temperature and salinity with depth. Hurricanes, especially slower moving ones, cause the temperatures in the sea surface to cool by bringing up deeper waters to the surface, like we saw in the last slide. Since ocean heat is a major source of cyclone energy, it causes a negative feedback that hurts the intensification of the storm. The way the ocean is stratified, both in temperature and salinity, are thought to control the amount of this cooling. Lev aims to further understand the exact roles these profiles have on the cooling, and overall he hopes to relate this back to improving intensity forecasts. Tori White studies various impacts that hurricanes have on our coasts. These impacts include storm surge, flooding, and coastal erosion. In addition, he examines the adverse effects of global climate change, such as increased erosion, flooding, saltwater intrusion, and sea level rise. He researches how storm surge coupled with king tides exacerbates flooding in coastal areas. Furthermore, he examines adaptive measures to preserve our coasts, such as beach nourishment, construction of sand dunes, elevated roads, one-way pumps, improved stormwater management, and elevated seawalls. Lastly, he compiles the data and communicates science to viewers, and forecasts the weather as an on-air meteorologist for UMTV's Canscast. So I'll pass it off to Quinton to give you a recap on the 2021 hurricane season forecast.
Yeah, thank you, Kurt. So that was a glimpse at some of the exciting research happening here at the Rosendale School. Now let's move on to the 2021 Atlantic hurricane season outlook and the implications this has on you and us in the South Florida area especially. So every year, a number of research institutions, including government agencies as well as universities, use a number of metrics, including forecast models, including climate simulations, climate outlooks, statistical models, and basically look at conditions in the Atlantic and predict what they might be like overall in the season to try to get an estimation of what our hurricane season will be relative to normal. Normal being, in this case, about 7 hurricanes per year. So we've had a number of predictions come in from various institutions. These 3 are governmental agencies. On the left, we have the European Centers for Medium Weather Forecasting, which is predicting above average season, the UK Met Office, which is predicting about a near average season, and the US National Oceanic and Atmospheric Administration, which is also predicting a slightly above average season. Several other universities, including Colorado State, University of Arizona, and Tropical Storm Risk Institute over in London, are also predicting above average season. Taken together, most outlooks this year are predicting a slightly above hurricane season in the Atlantic Basin. So why is that the case? Well, first of all, let's dig into a little bit more about NOAA's prediction this year. So NOAA is predicting about a 60% chance of an above normal season, a 30% chance of a near normal season, and a 10% chance of a below normal season. And this corresponds to roughly 13 to 20 named storms, which include tropical storms and hurricanes, from between 6 to 10 hurricanes and 3 to 5 hurricanes that reach category 3 or higher, which we call major hurricanes. Now, it's important to point out here that these are forecasts and they can change throughout the year. So later in the season, all of these institutions do update their forecasts. So please, definitely stay tuned to see how things look in August and September as we're in the middle of hurricane season. So why is it that we're expecting a slightly above average season? Well, it actually comes down to the 3 main ingredients that we need to form hurricanes in the Atlantic. So most hurricanes occur in this red outline box in the Atlantic Ocean. They tend to occur in this red area. You need 3 main ingredients to get hurricanes that both develop and thrive. For one, we need an increase in sea surface temperatures. We need warm ocean waters that provide the energy for hurricanes. We also need a moist atmosphere. We need a lot of water vapor in the atmosphere because thunderstorms and clouds make up the majority of what a hurricane is, and we need them to be able to form readily, which we need moist air already in place for them to do. Finally, we need what we call favorable winds. Kurt mentioned before this thing called vertical wind shear. And so we need the winds at the bottom of the atmosphere to roughly match the same direction and magnitude as up high in the atmosphere before a hurricane can really form. Otherwise, these winds can tear apart a hurricane before it has a chance to develop. So these are the 3 main things we need for a hurricane to form. And when we look at these seasonal outlooks, we see that there are a few things relating to these conditions that could make hurricanes more favorable. For one, this year, we've already seen the subtropical waters are slightly above average in temperature, as depicted by this graphic showing the deviation from climatology, even though the tropics are roughly around normal. And this could indicate slightly more energy for hurricanes to form, and thus a potential for more storms this year and more intense ones. We also might have more favorable winds this hurricane season. There's a phenomenon out in the equatorial Pacific called El Nino or La Nina. El Nino is a warming of the surface of the ocean waters in the equatorial Pacific. And this warming actually causes this what we call the Walker circulation, a big circulation in the atmosphere that actually basically extends across the world and causes the winds in the Atlantic, which is well far away from the Pacific, to be unfavorable. This year, we're not expecting El Nino, which means winds could be more favorable for hurricanes. In fact, right now, the best estimate for what the El Nino La Nina condition will be this season is what we call neutral, which means that there's neither an El Nino or La Nina, meaning that winds would be more favorable for hurricanes than they would be in El Nino. And so these are the largest factors, but there are tons of other factors that seasonal forecasters look at to take into account for these forecasts. One thing we want to reiterate, though, is that seasonal outlooks do not forecast how many storms could make landfall. You could have a below average season and still get tons of US landfalls. You could have an above average season and not get many landfalls. So what we like to say is it only takes one hurricane and you should be prepared. And so to talk more about how you can get reliable information this hurricane season, I'm going to pass it off to Mary Beth.
Thanks, Quinton. So it's very, very important to make sure that you are getting reliable and up-to-date information before, during, and after a tropical cyclone to maximize protection of yourself and of your loved ones. And so with a lot of different social media outlets or places to get information, it's hard to know where to find this reliable information. And so the Rosenstiel School has actually compiled a good list of websites, and you can find this on hurricanes.rasmus.miami.edu/hurricane-portal. That's also being highlighted in the left-hand side. So the National Hurricane Center can be accessed at nhc.noaa.gov. And this is a really good centralized location to find a lot of information. And so you can get information about any active storm in the entire Atlantic basin. And so one thing that you can find is the cone. And this is something that you probably have typically seen associated with a storm. And this gets updated frequently. And also on this website, you can get more of those impact-based projections like wind speed probabilities. And we'll go into a little bit more about what each of these means. So first for the cone, this image is the same image as before, or showing the same thing as the image as before. It's just fancier and nicer looking here. And this is often what you see on the news. But what is important is to understand what the cone is actually telling you. And so the numbers on the cone here are telling you the forecasted category of the storm. Now, the category of a storm is only based on wind speed in the center of the storm. It is not based on impacts or size. And furthermore, the shaded area here within the cone is only giving you a 66% chance that the eye of the storm will fall within this cone. And so let's look a little bit more about how this cone is actually formed. So here we can see the Florida Peninsula, and let's say that we have a hypothetical storm off the coast. And so here is our cartoon image of the hurricane. And now using our forecast models, the hurricane forecasters can make a prediction of where the eye of the storm will be after 24 hours. And that's marked here by the red X. Now there's uncertainty and error associated with these forecasts. And after one day, the average error of the location of the eye of the storm is 50 miles. And so then we run it out to 3 days, but now the error has grown to 120 miles. And then 5 days, we have the predicted eye of the storm with an error now of 240 miles. And so we use these as radii. We draw circles around the forecasted eye, and then we just connect the dots. And this is how the cone is made. And so again, it's giving you a 2/3 chance that the eye of the storm will fall within the cone. But there are really important things that the cone does not tell you. First of all, it's not telling you the impacts from the storm. And so as discussed before, flooding, tornadoes, storm surge are all deadly, costly impacts from a storm that we do not see from this cone. Second, we have no idea about the size of the hurricane. And so it's just telling you where the eye of the storm is. But by looking at that satellite imagery alone, we know that storms can be much larger with the impacts extending far outside the cone. So for example, let's say this storm was perfectly predicted, and after 5 days, the eye of the storm is where that red X is. A lot of the Florida Peninsula could be experiencing impacts from that hurricane, which means it's important to be prepared. And then lastly, there's no actual uncertainty conveyed for an individual storm. Since the size of the cone is fixed based on the average error, we don't get any information about if a storm is in a more favorable or less favorable environment for predictability. And so it can't be changed based on a certain storm. And so that's why we like to use other graphics that show more of the impacts and how you should be prepared. So here we have an example from Hurricane Dorian back in 2019. And when this storm was off the coast of the Bahamas, you can see here in the left-hand side, the forecast for the tropical storm force winds, which means 39 to 73 miles per hour. Now, it's really important to remember how strong 39 miles per hour winds can be. And so tropical storms often get disregarded because they're not even hurricane force winds, but it is certainly not safe to be outside. Especially to go surfing, even though the winds, the waves might be really good, the storm surge, the flooding, the dangers that come along with a tropical storm force are still very high. And a good example of this was Tropical Storm Isaias last year, which was a tropical storm and then upgraded to a Hurricane 1, but it was the third costliest storm of last season. And so the level or the category of the storm is not the only important factor. So going back to this image, here we see that Miami is on the edge of the cone, but we still had a 60% chance of tropical storm force winds. And then you can also find the hurricane force winds projection. And we had a 10 to 30% chance of these winds. And so this graphic is better to look at because it's more storm dependent. Another good place to find reliable information is Tropical Tidbits. And you can find that from that hurricane portal on the Rosenstiel School website. On this website, you can find model runs from the American model and the European model, as well as more localized forecasts. You can also see satellite imagery from any storm happening around the globe. And what's neat is that you can find information from the hurricane flights, from the hurricane hunters, some of which worked across the street here. Brian McNulty, the Canes on Canes mentor, also has a fantastic website full of analysis products, satellite imagery, broken down by region, as you see here in the left-hand side. And then lastly, the SIMS website out of the University of Wisconsin-Madison gives really interesting satellite imagery of different variables such as dust that's in the atmosphere that can affect how hurricanes form. So in summary, the 2021 hurricane season is expected to be more active than normal, which means more tropical storms and hurricanes due to the factors that are happening all around the globe, such as El Nino in the Pacific, tropical Pacific, and higher sea surface temperatures in the subtropics. Now, this is not saying that we know any information about where these storms will go. So while a more active than normal season is predicted, that is not giving any information about if there will be landfalling storms. And lastly, it's very important to get up-to-date and reliable information on the forecasts and the risk. And you can find this from the National Hurricane Center and your local National Weather Service office. And you can find more information on the websites discussed. And so no matter what the yearly outlook is, it only takes one. So you should always be prepared as if there will be a landfall. And so now I'm going to pass it over to Torrey White, who's going to talk about hurricane preparation.
Thank you, Mary Beth. So it only takes one. While we are expecting a more active season than normal, remember it only takes one. The Miami area has been really lucky in recent years, having had 3 near misses in the past 5 years. What we have illustrated here for you is the hurricane force wind swaths near South Florida from 2016 to 2019. We have Irma in green in 2017. We have Matthew in red in 2016. And then we have Dorian in yellow in 2019. So some of the things we can do to stay informed: know your area, sign up for local alerts such as Ready Miami-Dade app and the UM and notifications. You need to build a disaster kit, make a plan that includes evacuation routes, and prepare your home in advance. Know your zone. In Miami, hurricane evacuations are based on storm surge risk. This depends on your county and region of the US, so check your local emergency management office. Also, have multiple evacuation plans, one primary and one backup. Things to consider: how and where you will evacuate. Ideally, choose a backup location in a different direction. What will you bring? Focus on essentials such as medication, pets, personal and health documentation. Also, prepare a go bag of supplies that are portable and ready to go. Mandatory evacuations are mandatory, but if you leave voluntarily, make a decision early and stick to it. Here are some aspects of evacuating that you need to consider in light of COVID-19. Have spare masks and disinfectant in your disaster kits. If you plan on evacuating to out of state, be aware of local rules and regulations. Ultimately, you will need to make decisions earlier than you would have done in previous years. Stay informed. Don't make a plan and sit on it for 3 months. More advice can be found at ready.gov/evacuation. So, other things to consider: have 1 gallon of water per person per day for 1 week. Non-perishable canned foods for at least 3 days, prescription medication, hygiene items, first aid kit, charged mobile devices and portable charger, flashlights, battery-powered radio and extra batteries, important documentation, insurance, phone number lists, bank account numbers, social security card, and proof of residency. Add personal protective equipment and disinfectant to your disaster kit as well. The US Gov has released advice and shopping lists for hurricane kits here at www.ready.gov/kit. Be prepared. Even if you have an existing kit, check to make sure things aren't expired and batteries work. Also, make sure your car is filled with gas. One tip is to fill up when there's actually a potential system out there. One thing you would hate to happen is to try to evacuate and you run out of gas on the highway. Move yard furniture inside, put up hurricane shutters, fill bathtub with water, unplug electronics, and evacuate when told. Also check with local emergency management. Do not leave your building unless there's an immediate threat to life. So stay indoors during the passage of the eye, stay away from windows. If your home starts to flood, turn off the electricity and the main breaker. Get under a mattress if you feel your home starts to fall apart. So injuries occur after the storm has passed, and there can be many hazards. So only leave when authorities tell you to. Be on alert for boiled water notices. Watch for live escaped animals such as snakes. Watch for down power lines and electrical wires. Watch for debris and falling items. Empty standing water to prevent mosquito breeding, and take pictures of damage for your insurance provider. Loss of essential services can occur for a week or longer, including electricity, water, internet, and cellular service. If possible, stock extra prescriptions and an alternate source of power for electrical medical equipment. Tap water may be unsafe to consume after a disaster. This is why your kit should contain drinking water. Battery-operated radio can help you get information. Please be aware of carbon monoxide poisoning. Do not operate grills, automobiles, generators, and other combustion processes indoors without proper ventilation. Tragically, 8 people lost their lives in this and the aftermath of Hurricane Laura back in 2020. So what can you do now? Check your zone, start making your evacuation plan. For tomorrow, have conversations with friends and family about your plan and start building your disaster kit if able. If you plan to go stay with friends and family inland, make sure they're okay with it and that you have a backup. So our additional resources: consider FEMA, the CDC, and READY. At this time, I'm going to toss it over to John Gulla with Emergency Management.
Thank you, Tori, and good afternoon, everyone. My name is John Gulla, and I'm the Director of Emergency Preparedness here at the university's Office of Emergency Management. And as you may imagine, that means I spend a lot of my time thinking about and planning for hurricanes, communicating and coordinating with campus leadership during the season, and leading response and recovery efforts on the campus should we ever experience any impacts. We also offer training to our community on personal hurricane preparedness and exercise our existing hurricane plan with our department leaders across the university to practice and improve on those every year. I want to thank the Canes on Canes team again for bringing forward this important information to our local community, and to reiterate that the time to prepare is really now. Tori touched on COVID-19 a little bit, and while we're in a far better place than we were last year, I know we're not completely out of this yet either. we should use that experience and what we've learned over this past year. I know we'll all remember the toilet paper shortages and other things. So go out and get your kit and supplies together now, like Tori said. Know that you need to do this now and not wait till you hear the news saying we're inside the cone to start doing so. So I'll be standing by in case there are any questions specific to university hurricane planning efforts, and just say thank you again, all of you, for attending and taking the first steps towards being better prepared. And with that, I'll pass it back to you, Quinton.
All right. Well, this has been a great presentation, I think, so far, and I hope you've learned a lot. So just to summarize before we go to Q&A, hurricanes are a very complicated phenomena, and the Rosenstiel School is committed to pioneering research to better understand these systems and better predict them. Now, the 2021 hurricane season is expected to be more active than normal, but even if it wasn't, even if I was here saying, no, it's actually going to be below average, you should still start preparing now. It only takes one hurricane to cause devastation. This year, just like last year, you'll have to be more prepared because we're still intersecting hurricane season with COVID-19. And that means you're going to have decisions made earlier and be a little bit more aware of local rules, regulations. So the thing, if you take away nothing else today, is today make your evacuation plan. Tomorrow, start building your disaster kit or updating it. And finally, make sure you stay informed from good sources of information like the Hurricane Center and local media outlets. So at this point in time, I'm going to pass off to Mary Beth, who's going to be helping basically distribute Q&A questions to all of us. And so if you have questions, if you haven't typed it up now, go ahead and do so. And remember to visit our website here if you want to learn more about our organization.
Great. So just a reminder to everyone, you are welcome to put questions in the Q&A tab. And so our first question is for Tyreek. What caused Superstorm Sandy back in 2012 to be such a major event in the Northeast, particularly in the New York, New Jersey area?
So with storms like this, it's important to note that the category isn't the only thing that tells the story about the storm. And there's other impacts that may happen because of like how the size of the storm and how fast it's moving and other things like that. For the case of Sandy, at the time, since it was in New York, it wasn't categorized as a tropical cyclone, but it would have been equivalent to minimal category 1. And also with Sandy, the storm was very large. And with the size of the storm being that big, the winds are also greater, which makes the chances for storm surge worse. And then it also occurred during a high tide, which caused storm surge to be even greater than what it was. So those are the things that made Sandy extremely dangerous.
Great, thank you. So now for Kurt, is there any ongoing research on how to stop, delay, or decrease a hurricane?
Thanks, Mary Beth. So that's a topic that comes up a lot. And the government has actually put a lot of research into this. There was a project in the 50s and 60s called Project Storm Fury, where they tried seeding storms to stop them. But what they found out is that hurricanes go through eye wall replacement cycles. So even if you destroy the inner eye wall, another one forms around it and then replaces it. And so overall, hurricanes are just incredibly powerful. They produce like the world's level of global electricity consumption in a matter of hours. And pretty much any method that we would have to stop a hurricane would just not be cost effective. It would require just such a grand scale that it's not worth it. And another thing to note is that hurricanes are kind of an important part of the climate system, and they transport heat from the tropics to the equator. And so there could be a lot of potential side effects trying to stop these storms.
So I guess we're not getting rid of hurricanes anytime soon. Next, Quinton, how does Canes on Canes plan on which public communities to perform public outreach in? Are potential location or societal risk factors such as low-lying areas, low-income areas, Spanish or Creole majority-speaking areas considered when planning?
That is an excellent question, and that is something we do take into consideration. Here in Miami, for example, we try to reach out to local communities that are, for one example, low income, but also low-lying regions. Miami is a huge city with a mix of different, with a number of different populations, a number of different languages spoken, and it can be really difficult to reach all those communities, especially when you're trying to communicate a message like hurricane preparedness. One thing we also try to be really courteous of is that it is hard for, when you make disaster kits, it can be really hard for some people to have the funds and have the means to make a disaster kit with all these supplies in advance. So one thing we really try to recommend to communities is that basically get what you can. Some supplies are better than no supplies at all. And so things like canned foods or like water, you know, just buying a little extra every time you go to the grocery store can be an easier way than going out at the beginning of the season to really, to purchase a little in advance. But yes, that's a great question. We do try to focus on those communities that are hit harder by hurricanes and may not have the means to evacuate. We also try to be really courteous of, or try to spread information that Miami-Dade County puts out, because there are a lot of local resources, such as local hurricane shelters, and we really try to emphasize those solutions as well, because as you might imagine, sometimes it's difficult for people to evacuate out of a region. So yes, that is something we do consider as a group, and it's something we're trying to get better at in the future too, especially with hopefully being able to do more in person.
Okay, so a question that is often on people's minds is hurricanes and climate change. So Kurt, with warming ocean temperatures due to climate change, would it end up enlarging the area where hurricanes form in the Atlantic Ocean?
Thanks again. So that's kind of a complicated question. So we do expect that, I mean, hurricanes require warm water to form, and we do see that waters at higher latitudes are getting warmer. There have been recent tropical cyclones that have reached stronger intensity or formed further north than we would normally expect. But that's an open area of research, and there's lots of nuances that make this a little bit more complicated to understand. So probably, but we're still not sure.
Thanks. And another thing I want to reiterate is that no one storm can be attributed to climate change. Climate change ends up changing the averages over time, but you can't just say that one specific storm was caused by climate change. So now, Tyreek, how do hurricanes get their names?
So the World Meteorological Organization, they have a list of male and female names, and they rotate them on a cycle of 6 years. And if a storm is significantly catastrophic, they'll retire that name and replace it with a new name. And then when we went over the actual allotted names, like last year, they used the Greek alphabet, but now it's actually retired, and they have a list of more names to use.
Thanks. So, Kurt, can you explain why tropical storms often bring more flooding than hurricanes? Is this largely a function of ground speed?
The most devastating storms, or at least the most devastating floods produced by hurricanes, it's largely a function of ground speed. So very slow moving storms like Harvey and Florence, it's the speed that's most important, not the intensity. So I'm not entirely sure that tropical storms are wetter than hurricanes. It could just be that when you have a slow moving storm that's over land, it will tend to weaken. And so a lot of the flooding rains come when the storm is a tropical storm. That said, every storm is different. You can have very large, wet tropical storms that can cause billions of dollars in damage. So it really is dependent on the storm speed and, of course, the individual characteristics of the storm.
And so, Quinton, is there a specific model that you think is better or more superior than another model?
I don't think that's, I think as a meteorologist try to use a combination of models. Some models have advantages over other models. And we also try to use a type of model called ensemble models, where basically a single model, such as the American model or the European model, is actually run like 50 or 60 times to try to get the idea of predictability out of that model. So there's not really a particular model that's better or worse. It's more about looking at the various models that are giving answers and recognizing that any one answer is not necessarily the right answer. But if we have a lot of models saying something similar, it gives meteorologists more confidence in what that storm might be doing. And ensemble models as well help us try to quantify how predictable or unpredictable storm is. And one thing the Hurricane Center really likes to do is communicate, risk in the sense of like, well, one storm might just be more unpredictable. The models might not be handling it very well. And so they try to emphasize that, okay, well, the cone is saying this, but we're still not as sure as we might with other storms. So yeah, I don't think there's one model that's worse or better than the other. I think it's more, meteorologists use a combination of, 7 or 8 different main models to kind of get an idea of what things are happening.
Okay, so for John, regarding the intersection of hurricanes and COVID-19, do you think that it would cause limitations in the existing community hurricane shelters?
So I can speak about last year, and yes, there absolutely, the physical distancing requirements did cause some limitations on some of the Miami-Dade County shelters. With that in mind, I mentioned we're in a better place this year with vaccinations, and I know Miami-Dade County and other counties across Florida are thinking about how we can best handle and structure for this year. But knowing that not everyone in the population at this point has been fully vaccinated, it is likely that we'll still need to have increased physical distancing. That all said, I do want to point out that although we have these two things in mind in terms of thinking about safety, COVID and hurricanes, we have to, in emergency management, always deal with the most present threat to our safety, which in that case would be hurricanes. So a hurricane impact is really going to be far more significant, and moving people out of evacuation zones with storm surge would be the right move there. So we still encourage people, hey, even though you probably are thinking about the effects of COVID-19, we do want to consider the more present threat there being that, in other words, COVID-19 should not be a reason for you not to evacuate. So just keeping that in mind and moving forward, there may be some limitations on community shelters, but they are planning for that in advance. And these are things that are occurring. And now we've had a whole year. So there's much better planning in place to deal with this should we need to.
Thanks, John. So for Kurt, how do we know if there will be an El Nino or not this season? And then what does that mean for hurricanes?
Thanks. So El Nino or the ENSO or the El Nino Southern Oscillation is a really slowly changing phenomenon. So it has a cycle of 2 to 7 years. So it's not moving very quickly. And so earlier this year, we were in a La Nina. It just weakened last month past the threshold to a neutral state. And so just based on the fact that we're in a neutral state right now, we can probably predict that we'll be in a neutral state several months from now. But we do have ocean models that look at the ocean currents, as well as the wind speeds at the surface and the subsurface ocean water temperatures. And they can have some skill in predicting how the water temperature will change. These models this year are predicting basically neutral conditions, although there's still quite a bit of spread. And so during an El Nino year, which is when there is warmer waters off the coast of South America, we tend to get more of that vertical wind shear that I was talking about, the difference in winds at the top and bottom of the atmosphere. And so during an El Nino, there tends to be less hurricanes in the Atlantic. However, in neutral and in La Nina years, there's an average amount of shear, and so we generally see more activity.
Thanks, Kurt. So our next question for Quinton, with Miami's vulnerability to hurricanes, is hurricane resistant architecture something that researchers can help implement? And if so, what types of infrastructure can be put in place to help with hurricane protection?
That's a really great question. So there are a number of what we call U-Link projects, which are interdisciplinary projects across university that are working exactly on that question, the architecture, engineering, atmospheric science departments. And it is a very active area of work here at the University of Miami. And they're also collaborating with local Miami-Dade offices to investigate these issues, which includes designing coastal structures that are resilient to high winds and storm surges. So one example that's been implemented in other parts of the country have been seawalls, which there was actually a very high profile discussion about that in New York Times in Miami recently. But they're also, like we mentioned earlier, the sea hives, which is another sort of coral related collaboration on whether or not that can mitigate winds. So yeah, there's a lot of work to be done on that. One thing that in, for example, Miami-Dade County and other South Florida areas, is also building the local, building codes to be more resilient to hurricanes, so that even if you do get storm surge or you still get high winds, that buildings don't take as much damage. But yeah, great question. It's something that's actively being worked on. It's probably one of the most important questions in this field.
And our last question of the day for Tyreek: are bigger storms always stronger, or does it matter?
Bigger storms are not always stronger, but the bigger the storm is, the more widespread the damage will be. And for example, in the case of the first question I answered, the wind field is also greater, so that can increase storm surge. But you could have a very large low category storm and a small category 5 that will do more damage in a local area. But the larger storm would have more widespread damage.
Okay, thank you very much. And I'll hand it back to Quinton to wrap up.
Well, yes, thank you everyone for coming today. If you have any additional questions that we weren't able to get to in this session, please contact us at this email address I pointed out here, and we're happy to answer via email. We'll also be following up with a letter with a little bit more information and a flyer that summarizes the information we went over today. I know there was a lot of information. I know it could have been slightly overwhelming. So by early next week, we'll be sending you a summary in the email you registered with some more information that summarizes like the disaster kit and summarizes things like, the before, after, during, and after tips as well. So be on the lookout for that, and thank you for coming. We are looking to spread our outreach as much as possible. We can do things virtually, so please, if you know someone, if you're a teacher, if you know a teacher, if you know someone in your community who would love to have one or two of us come in person or virtually talk about hurricanes, we can do basically anything and cater to any crowd, and we look forward to hearing from you and hope you learned a little bit more about hurricanes in the season today.